geometry. We are going over some difficult algebra 2-ish questions that bring in a lot of different concepts that we've talked about before. We're multiplying roots, that's kind of the main thing, but for these three here, we do have to go back, talk about the distributive property, old man foil, crab claw, the box, any of those things when we have two binomials here. Yes, Paul? A notebook?
Yeah.
It'll cost you a pass, but yeah. So distributing in this first one, we can't combine 2 root 2 and 4 root 4 with addition because the roots aren't the same. Is he right? Right?
Yeah.
Right. So we're going to have to distribute it. And so 3 root 3 times 2 root 2, that gives us 6 root 6. And if we want to simplify the 4 root 4 first, because that root 4 does equal 2, this essentially gives us 8, 4 times 2, which makes this second multiplication a little bit easier. We don't have to simplify later on then. But 3 root 3 times 8 is 24 root 3. Okay, if you didn't simplify that to be 8, you would have gotten 12 root 12. But then that root 12 should be simplified to 24 root 3 in the end anyway. Okay, and so we've got 6 root 6 plus 24 root 3. Anything we can do?
Yes. No.
Nothing we can do here, right? The only way to get like roots is by simplifying. I can't multiply this by root 2 to make it root 6. It's not a fraction. I'd literally be changing the equation if I did that. I have to leave it the way it is here. We're done. Nathan.
When are we going to use this?
This lays the groundwork for algebra 2, which, like, for example, if you ever asked me last year, when are we ever going to use FOIL, you would not be able to multiply this if you didn't understand FOIL or crab claw or the box. Hold on. That was the groundwork for this. Okay? This is the groundwork for algebra 2, which may have mentioned this before. You can thank all your technology, all the games you love to play, all of that cell phone, the apps, the Tic Tacs, all that stuff. You can thank algebra 2 for that. Because without algebra 2, there would be no cell phone signals. There would be nothing wireless, any of that. No Wi-Fi, all that stuff. Okay? So, not that all of you are going to go into those fields, but those that do, you're going to need the groundwork. Some of you might never use it again. That's great. But thankfully, there will be those who will to give you the luxuries that you all enjoy. Naveen?
Never mind.
Okay. Next one. Raise your hand if you did old man foil. Oh, poor old man. Raise your hand if you did crab claw. Raise your hand if you boxed it. And we'll talk about the box.
Box.
How the box works. You are making a 2x2 box because you have a binomial times a binomial. And right off the bat here, I'm seeing a potential mistake. Make sure that you've got negative 6 root 2 written here, not just 6 root 2. Folks. So now, remember the box method, how it works is that when you multiply, the product of the terms goes in each of our 4 squares here. So 2 root 3 times 2 root 2 is 4 root 6. 2 root 3 times root 15 is 2 root 45. Negative 6 root 2 times 2 root 2 is negative 12 root 4. We'll worry about simplifying in just a bit. And negative 6 root 2 times root 15 is negative 6 root 30. Okay? Now, each product, if you're doing this, showing each and every step here, each product gets written down below. Plus 2 root 45, minus 12 root 4, minus 6 root 30, and each gets simplified in order to combine the like terms that we can. Now we're adding and subtracting here. We multiplied to fill out the box, but now we're adding and subtracting the terms. 4 root 6, can we do anything there? No. 2 root 45?
Yes.
Yes. What does that break down to
9
be?
and 5.
We use 9 and 5. That root 9 becomes a 3, making this 2 coefficient a 6, and we're left with the root 5. Negative 12 root 4, what does that become? Negative 24. Negative 12 times 2, because root 4 is a perfect square. What's that? We're not done yet. Just hold up. Yeah?
How do you get 6?
Because root 45 is root 9 times root 5. The root 9 becomes a 3. So we essentially get 2 times 3 times root 5.
Oh.
And 2 times 3 is the 6. And then negative 6 root 30, anything leave there?
There's nothing.
Nothing. 2 and 15, not perfect squares. 3 and 10, not perfect squares. 5 and 6, not perfect squares. So negative 6 root 30 is our answer. Okay. Now, as far as putting in the correct order, it's not like exponents are, where there's like a standard form for it. Typically, your constants would come first. And after that, it's really just kind of whatever you want to do. And the reason why your constant would come first is because some of us are not being very neat in our writing. And so if you have negative 6 root 30, and then you write your plus 24 after that, you kind of write it like that. Well, wait a minute now. Is that root over? Is that negative 6 root 54 that you meant? Or is it, right? So there's not really a standard way, but typically the constant would come first. Also, negative 24 is a rational number, whereas the other ones are all irrational numbers. So, Colin.
In your video, you said that the constant always comes last.
Did I?
Yeah.
Yeah.
I had 21 though.
You made an oopsie, dude. You made a mistake.
Sing it. You made a little. Sing it.
Yeah.
Is that the right answer?
Well, apparently in 2022, the constant went last. In 2023, the constant goes first. Just keep you on your toes. It's not a whoopsie-doo.
It's 21.
That's probably one of those things where I just decided the way that I wanted it, and now this year I feel differently.
It's 21.
No,
Hey, Mr. Schultz.
21, whatever.
What about the number?
We're not there yet, Finn. We're not
We're
done
not
yet.
there.
Oh.
Let's do something different. Raise your hand if you want to do old man foil. What?
I still don't
What's your question, Paul?
wait, how did you get 24 again?
Because root 4 is equal to 2, so this essentially says 12 times 2.
Oh!
Raise your hand for old man foil if you want old man foil. Raise your hand for crab claw. The foil wins. Okay.
How about bar?
We already did that.
No, we didn't.
Old man foil stands for first, outside, inside, last. So the first terms in each expression, 6 root 3 times 3 root 2 gives you 18 root 6. The outside terms, 6 root 3 times negative 5 root 18 is negative 30 root 54. The inside terms, negative 7 root 2 times 3 root 2 is negative 21 root 4. And the last terms, negative 7 root 2 times negative 5 root 18 is 35 root 36. Well, that works out dandily. Okay. Now we simplify. 18 root 6, can we do anything there? No. Done. Root 6 can't be touched. Negative 30 root 54. What do we come up with there? 9 and 6 is the factor pair. That 9 becomes a 3. Multiplied by the negative 30, negative 90 root 6. Ooh, I see we can do stuff. Negative 21 root 4. That root 4 is equal to 2. So negative 21 times 2 is a negative 42. And 35 times root 36, the root 36 is equal to 6. So 35 times 6 is a positive 180. Okay? And there are things we can simplify now. That 18.6 and then negative 90 root 6, what does that simplify to be? Positive 18 root 6, negative 90 root 6. What do we get?
Negative 72.
Negative 72 root 6. And like I've always said, that constant should come last in your expression here. Okay?
Like you always said.
Always said that. Never have I deviated.
What is that?
And then our constants, 180 and negative 42. If you subtract 42 from 180, Edward, what are we doing here? Can you tell me, is that correct? Let you check. While you do that, it is a positive 138. And so negative 72 root 6 plus 138 should be the answer. Eli, what'd I do?
35 times 6.
Yeah, it should be like
210.
Oh!
Oh,
Yeah.
yeah.
Whoopsie do, I made a mistake. That's just part of what makes math great. We learn and we grow, and so can you. When you say, whoopsie-doo. Yeah! So, thank you, Eli. Negative 72 root 6 plus 168 is the final answer.
This makes more sense.
Nathan Terrell. Okay. All right. Any questions on that section? There will be one like that on your test. I can tell you that right now. So you will need to know FOIL, crab plot, or box, and how to simplify it when you are done. Okay. Next section. It's a long one.
What about the number?
Cole, are we done correcting yet? Yes, we do, Cole. Yes, we do. This is a good time to review how to rationalize, because you cannot have a square root in the final answer of a denominator. Yeah, I said that right. So to rationalize, recall you multiply by the root you want to remove over itself. And so this would be 5 root 3 over 3. Right? 5 root 3 over 3. The denominator becomes a 3 because root 3 times itself is root 9. Root 9 is equal to 3. Okay? This goes back to CO61 part 2. The next one, we're multiplying by root 2 over itself. So root 2 over root 2. That gives us 6 root 2 over 5 times 2. Right? Because root 2 times root 2, that's what rationalizing does. It cancels out the root for that term. And so we get 6 root 2 over 10, which reduces to be 3 root 2 over 5, and that should be your final answer. That should be your final answer. Yep. Simplify, simplify, simplify. Yes?
I'm so confused about the top. Question.
I have to save it. I can't go back right now. Next one, we're multiplying by root 3x over root 3x. And so that gives us 3 root 33x over 5 times 3x, because in the denominator, that root 3x times root 3x cancels out. We got the 3x. Nothing we can do with the 33x, although before I do my final multiplication here, what can I simplify? Just it'll save us a brief step going forward. Paisley?
You can simplify it to be 3
111.
with the 3 and the square root of 11x.
What?
No, because 3 and 11, neither of those are perfect squares.
Oh, right.
111.
Sorry.
Yeah. Real? I can cancel out the 3's, right? Because those 3's are the same value. If I didn't cancel out the other 3's and I multiplied 5 times 3, I'd get 3 and 15 anyway, which I'd then have to simplify down to be 1/5. So why not just do it now? Cancel out the 3's, I'd factor out eventually anyway, so that all I'm left with is root 33x over 5x. The x's I can't cancel out because one's under root, the other one isn't. Okay? But the 3's I can, and I end up with root 33x over 5x. And lastly, the root 18, I can simplify now, I can simplify later, I'll just do it later. Multiply by root 18 over itself, which gives me 3 root 18 over 18. The root 18 can be simplified using 9 and 2. 3 times 3 is 9, so I have 9 root 2 over 18. The 9 and the 18 can be simplified to be 1/2, and so root 2 over 2 is your final answer. Okay? What happened to your pen?
That's a good question.
Can you go wash your hands and not touch anything? Keep it off of the desk
Yeah.
so you don't have to wipe anything up later on. Perhaps we could get a friend to open the door for you so you don't have to touch the handles.
Oh, friends.
What the fuck?
Yeah.
I know, but with that ink, you should go to the bathroom sink because that's going to splatter all over.
What in the flip?
Charlotte, can you go take care of that? Thanks. Folks, in the interest of time here, we're going to push this and the rest of the page off until tomorrow. So this, you should already have it done, but if you didn't, which y'all did, you get the number game. It's due tomorrow. Just this is more practice with the rationalizing. But the third page is basically dividing roots. which is basically just rationalizing, right? You've already divided roots when you rationalize something. When you get to this, 14 over 56 root 3, we've done that before. 1456 reduces to be 1/4, and then you rationalize with the root 3. You've been dividing fractions since PO61, or dividing roots since PO61 part 2, you didn't realize you were. Okay? Then, though, when you get to these end parts here, how do you divide fractions? Back to Nathan, a previous PO. How do you divide fractions?
You just flip them over.
You flip the second fraction and multiply, or cross products, right?
Products.
That's what I do.
Cross products and then rationalize, right? Cross products and then rationalize. So not as heavy of a homework assignment for tomorrow. Similar concept, a lot of rationalizing the denominator. Don't forget to rationalize your
That's now
denominator.
fine by me.
See, that's the net that was brought to me earlier.
I was
Which you know.
I was trying to kill it.
Please do, yeah.
Why give
Okay, any questions, comments, concerns, complaints,
No,
comments,
God,
congratulations, criticisms on this?
it there?
Sam, anything?
There's a nap.
Okay, that's what I'm at.
Don't
Don't forget to
forget to
like
like
and
and